Most people preparing for a SOC or SIEM interview make the same mistakes. They study tool, memorize definitions, maybe watch a few random videos, but when the interview actually starts, the question sounds completely different from what they practiced. So suddenly you hear things like, how would you set up SIEM? What logs we should ingest from SOC perspective? What is syslog? And that's where many candidates get stuck. Not because they don't understand security, but because they have not practiced how these questions are actually asked in real interviews. So I decided to build something different. Instead of random theory, I collected 100 real world SIEM, SOC L2, L3 interview questions, the kind that detection engineers, SOC analysts, blue teamers, and security engineers actually face. So we will cover them across 8 categories like SIEM fundamental, architecture, detection and rule, incident response, log management use cases, tool and platform, and some advanced scenarios. And the best part, more than 30 of these are real scenario walkthrough. So we have 100 questions plus 30 scenario walkthrough. So total 130 questions and answers I'm going to cover in this video. Meaning you will learn how to think like a detection engineer or SOC analyst, not just memorizing answers. So, if you are preparing for your SIEM role, SOC job, and trying to move into blue team, or just want to feel confident walking into an interview, this video might become one of the most useful resource in your preparation. So, hello everyone, InfoSec Pandey here. So, if you enjoy practical SOC and cybersecurity content like this, don't forget to like the video, comment, and subscribe the channel. Let's get started and master your interview. All right, so very first question we have, what is a SIEM and why does an organization actually need one? So in practical term, we can say SIEM is like a central brain of your security operations center. So it's a brain, and SIEM stand for security information and event management. So think of it as central nervous system of your SOC because it collect log from various data sources like firewall, endpoint, server, cloud, and then it is normalizing them and then correlating the events and alerting on suspicious behavior in near real time. So organizations need it because security data is scattered across dozens of systems, and without a SIEM, you are hunting threats in dark with a flashlight instead of a floodlight. So that means it needed because our system generate tons of log every day, and if we go line by line, we would not able to evaluate or understand the log pattern or log analysis, right? So that's where the SIEM come and play role. It normalize the log, it collect all the data, and it do the correlation and then alerting. The scenario we have here, interviewer says, our company is debating whether to buy a SIEM, make a case. So the answer you can give, you can start with compliance requirement like PCI DSS, HIPAA, SOC 2, all require log management. Then pivot to threat detection speed. You cannot detect a breach that started 60 days ago unless you have a correlated queryable logs, right? So you can mention SIEM is needed for two reasons. One is compliance requirement, because compliance requirement have a major pillar called log collection. So there are many compliance which require to collect you all the logs from many systems, and to fulfilling these you need a SIEM system, right? And the second point we have, SIEM is needed from threat response perspective. So if you have any security breach or security incident, you can properly investigate using SIEM logs by doing some correlations. So that's why SIEM is needed. Hope it is clear. And the pro tip is, You can mention both the security value and the compliance value. So security value have detection and response, and compliance value have audit trail, reporting, etc. So companies often buy SIEM for compliance requirement but get security as a bonus. All right, so second question we have, what is the difference between SIEM, SEM and SIEM? So SIEM means security information management. So this focus on long-term log storage for long term, like 7 year or 5 year or 1 year. So this is a kind of historian server which store log for long time. And then we have SEM. So SEM means security event management, that does the real time monitoring and alerting. So this is majorly used for security monitoring and alerting. So we can say it is a watchdog. So now the SIEM. So SIEM is combination of both security information event management. So this combines both. It store log and also do the security monitoring and the alerting activity in real time. So the modern SIEM have also evolved like UEBA and SOAR capability. So if I say modern SIEM, it is a combination of SIEM, SIEM, SEM, UEBA, and SOAR. And the scenario here we have, you might get asked, is your current SIEM more SIEM or SEM? So this is a great answer, and it shows you understand that most organization overinvest in collection and underinvest in real time correlation. So if you know the definition of SIEM and SEM, you can clearly answer this question, right? So the pro tips here is, this is a often warm up question. Nail it confidently and add that modern SIEM are evolving into extended detection platform, so you follow the industry. So you can mention all these things like SIEM, SEM, UEBA, and SOAR. So this is the modern SIEM. So this will show that you follow the current trend. All right. So the third question we have, what is log normalization and why does it matter? So log normalization. So log normalization means converting logs from different system into a common format. So suppose you have a window machine, you have a Linux machine, and a firewall system and some app server or database server, and they generate different logs, right? They have different schema. So converting them into a common event format or common log format is called normalization. Like here we have some common field example like source IP, destination IP, user detail, action, timestamp, etc. And without normalization you cannot write correlation rule. So normalization is important for correlation. So correlation rule that work across various log sources. Your rule to detect brute force would need 20 different versions, right? So that's why the normalization is needed. And the scenario we have, we are onboarding a new cloud provider and log look totally different from our on-prem gear. So how would you handle this? So you can walk them through like parsing the log, and then identifying the field which is called schema, identifying field like schema management, and then building a common event management or common event format, and then mapping and validating and test the event. So this is the complete process if you see any new cloud provider log. And the pro tip here is know at least one common information model, like Splunk have their own CIM, Elastic Common Schema in the Elastic, or OCSF. So mentioning a specific framework signals maturity that you understand the normalization. All right. So the fourth question we have, what is the difference between a true positive, false positive, true negative, and false negative in SIEM? So the answer here is true positive is like SIEM trigger an alert and there was actually an attack. So this is confirmed attack. Confirmed attack equal to true positive. And that's the dream of SOC team. And what is the false positive? So alert fired, but it is benign activity. And this commonly cause the alert fatigue territory. So that means like SIEM trigger an alert, but the activity was harmless. So like it caused because of some admin activity or you're testing some file or some internal system that's are expected performing any known activity. And what is the true negative? So no alert, no attack, all good. So that means suspicious. That means nothing suspicious happened and SIEM correctly stayed silent. So that means true negative. And the false negative, the FN. So attack happened but no alert. So this is most dangerous case. I would say the nightmare. And this is how the breaches go undetected for months or years. And the goal is maximizing true positive while minimizing false positive. So maximize maximize true positive and minimize false positive. So that's the goal of any SOC. All right. And the scenario here we have your SOC team is complaining about too many false positive from your brute force rule. So how would you fix it without creating false negative? So we can adjust the threshold. So if the threshold is set greater than 5, you can set it greater than 7 or greater than 8 or greater than 10. And then also you can change the time window. So time frame, if it is looking back for last 10 minutes, you can adjust it for 20 minute, 15 minute, 30 minute or 1 hour. So that's how you can reduce the false positive. Another thing you can do, whitelisting for your service account. So if your service account triggering brute force alerts or events, you can whitelist them, or you can use the contextual enrichment like your source IP is internal or you are using any automation tool. So all those things, if you include, your false positives will drop. And the pro tips here is in interview when you say you would tune something, so be specific always. You can mention how you can tune it. So like you can mention I would increase the threshold from 5 to 20 failed login over 10 minutes and exclude the service account in the finance automation OU. So this sounds way more credible than I would tune the rule. So be specific always and provide some examples and steps how you are going to tune it. All right. So the fifth question we have, what is UEBA and how does it complement traditional SIEM correlation? So a UEBA is like a user and entity behavior analytics. So entity is your IP, your app, your host, etc. So these are the entities behavior analytics. So that means machine learning to build behavior baseline. So there is a machine learning model which is analyzing behavior of the IP, host, user, app, and creating a baseline of it. And if it is find anything suspicious, then it is going to trigger that. So traditional SIEM correlation is rule based. So it is like if X happen Y time trigger an alert, but the UEBA is context based and context aware. So if user never log in at 3 a.m. from overseas and they never access the financier, this is anomalous. So machine learning model create a baseline, and if like it is find any suspicious activity, then triggers an alert. So UEBA catches what the rule miss. It is very slow and low process, but it is going to detect the very sophisticated attack, your insider threat, and some novel technique that don't have a signature yet. So it is not signature based, not signature based. It is behavior based. All right. So the scenario here we have a seam with 200 rules, but keep getting breezed. What is missing? So UEBA is the right answer. So if you are getting breezed and you have 200 alert and you are not able to identify any suspicious activity, then you should deploy the UEBA. Rule catches the known bad, but the UEBA catches unknown bad by learning what is normal looks like. So if I say the normal looks like, then that means the baselining. And the pro tip is there are some tools to know, like Splunk UBA, Microsoft Sentinel with behavior analytics, Exabeam, Securonic. So all the modern SIEM offer UEBA. Even mentioning UEBA exists and how it differs from rule-based detection put you ahead of most candidate. All right, then we have a next question here. What is an alert, an event, and an incident, and how do you relate in a SIEM workflow? So a event is a single log entry, single log, like a user logged in at 10:05 a.m. So this is a single log, but the alert is when correlation rule or analytics fire on events. So if X happen in Y time, then alert. So this is an alert. Like this user logged in from 3 different countries in 2 hours. So this is an alert. An incident. So an incident is when an alert is investigated and confirmed as real security issue requiring a response. So if it is confirmed attack, then it is called as incident. So incident is something that require immediate attention. So the workflow you can mention here, the event, and then we have a correlation of the events, correlation of various events. Then it is going to trigger an alert, and then we are going to triage the alert. And if it is a true positive, then it is confirmed incident. So if we see any incident, we can do incident response and then close the case. So scenario we have here, walk me through how an event become an incident in your SOC. So you can answer like this. You can describe the L1 analyst receiving an alert. So you can tell the complete flow, like L1 receiving alert and then reviewing the raw event in SIEM, and then enriching them with threat intel feed, and then escalating it to L2, and then confirming the incident and handle off to IR. So you can tell the complete flow, and this is a great answer. And the pro tip here is interviewer love when you describe alert triage like a funnel, like thousand of events, then 10 of alert and a few incident. So you can create a funnel like this. So like you have 10,000 events, and we all know all events are not security incidents or security alerts. So 10 events triggered as alert, and then 2 are confirmed incident. So this is how you can narrow down the funnel and describe in the interview. So it shows you understand the volume management in SOC. Question number 7. What is the difference between signature based and anomaly based detection in SIEM? So signature based match against known patterns. It is fast and low false positive for known threats, but blind to 0 days and novel TTPs. So that means if you have a list of IOCs, or you have integrated a threat intel platform with your SIEM, and if it is a matching those IOCs, then it is going to trigger an alert. So this throws very low false positive because it's a confirmed incident that provided by threat intel. And if it is matches to your data, then it is a security incident. But it is failed to provide the 0 days attack. So like if you don't have the signatures, you are not able to detect anything, right? Like an antivirus, so it only catches what it's seen before. But the anomaly based detections are established like a baseline of normal behavior and flag deviation. So that's where the UEBA come in the picture. So it catches the novel attack but produces more false positive because it is like analyzing your behavior every day and based on that creating baseline. So it may throw some false positive. And modern SIEM use both. So if we talk about the modern SIEM have threat intel integration plus UEBA. And the scenario here we have a threat actor is using a technique that has no public signature. How does your SIM catch it? So you can pivot to anomaly detection like unusual process trees or abnormal outbound data volume, first time seen behavior, MITRE attack coverage. So as I mentioned, this is where the UEBA come in picture and find these patterns. And the pro tip here is this question is really asking, do you understand detection strategy? So you can frame your answer like layered detection, neither approach alone insufficient. So you can mention both. All right. So the next question we have, what is a correlation rule? Give a real example. So a correlation rule is a logic that connect multiple event across the time or sources to detect an attack pattern. So why the correlation rule is needed? Because single events are often benign, right? So that's why we correlate the rule, and correlation rule reveals the whole story. For example, here you can see there is a failed login in 10 minutes. So failed login is greater than 10. So for example, you can see number one, failed login is greater than 10. Number two, time is 5 minutes. Number three, from the same source IP, same source, and one successful login from the same IP. Same IP, success. So this is a brute force attack, a classical brute force attack example. So this is a correlation rule here. You can understand. So correlation rule catches like password spraying, like each individual failed login is unremarkable, but a pattern is a brute force, then success attack. So this is going to catch the password spraying. So we have a scenario here. Build me a correlation rule for detecting a compromised account used for lateral movement. So the answer you can provide, you can look for a user authenticating to 5+ unique internal host. So suppose there is a user who is trying to access different systems, 5 unique internal host within 30 minutes. So especially outside of the business hours. So suppose it's a 3 a.m. So there is a user at 3 a.m. accessing 5 different system in 30 minutes. So by combining the rear for this user Kerberos ticket request, you can understand the correlation rule for lateral movement. And the pro tip here is when you give examples, always tie them with MITRE attack technique. So you can mention the MITRE attack technique as well when you are answering the question like lateral movement, or you're talking about the brute force and all. So you can mention the technique ID and sub ID. So T1110 and then .003 is for password spraying. So this, so you think in a framework, not just in a tool. All right, so the next question we have, what is EPS, the event per second, and why does it matter for seam sizing? So, event per second, the EPS, is the rate at which a seam ingest log data. So, this is a rate for ingesting data in seam, and it matters because most seam are licensed by EPS. So, the legacy based SIEM are licensed by EPS. All right, so the next question we have, what is EPS, event per second, and why does it matter for your SIEM sizing? So EPS, event per second, is a rate at which a SIEM ingest log data. So this is required for log ingestion calculation and licensing. So it matters because most SIEM are licensed by EPS. So currently the SIEMs are licensed by EPS or GB per day. So if you understand EPS, you will either drop your log or overpay for emergency capacity. So that means if you understand the EPS model and licensing for your SIEM, you can tune your logging, you can remove the junks and save some money because SIEM systems are very costly. So the sizing volume estimate EPS per log by source type, like window DC typically generate 500 to 2000 TPS under load, and the firewall generate 200 to 500 EPS, etc. So if you want to understand EPS calculation for various data sources, you can just drop your comment in the chat. I will create a separate video how to calculate EPS for various systems like Windows, Linux, your networking logs. So this will help you to sizing your seam, then multiplying by source count and adding a 30 to 40% headroom buffer. So if you're working as a detection engineer and doing some integrations, you will understand the EPS. And the scenario here we are onboarding 500 Windows server. How do you size the seam? So as I mentioned, if you want to learn how to calculate the sizing for Windows by EPS, you just drop your comment in the chat. I will create a separate video for that. And you can walk through average event per server, peak and average load comparison, and the storage returns and requirement, like 30 days hot, 1 year cold, and the licensing model, whether you want a EPS based or GB per day based. And the pro tip here is GB per day is the replacing EPS nowadays. As I mentioned, the modern SIEM tools are using GB per day, and also they have a model for pricing called pay as you go. So that means if you are ingesting 100 GB per day, you need to pay for 100 GB only. And that's where the GB per day play a vital role. Also know that the verbose lock like EDR, DNS can surprise you with 10x normal volume. So create a baseline, whatever needed, ingest that only and drop everything. Then the next question we have, what is threat intelligence integration in SIEM and how does it work in practice? So TI integrations or TI enriches the SIEM event with known bad indicators, and the indicators contains like IP address, domain, has, URLs, phishing emails, and feed like Virus Total, Alien Vault, OTX, Isaac feeds, or commercial platforms like Recorded Future, CrowdStrike, TI. So practically, your SIEM ingest TI feed via STIX and taxi protocols. So these are the protocols for TI integrations feed or file import. So you can upload your CSV file, then lookup table match incoming event field against IOCs. So if outbound traffic hit unknown command and control IP, you fire an alert automatically with the TI context already attached. So TI platforms are very important for SIEM because your SIEM doesn't understand the IOCs by default. So if you want to catch the known attacker's behavior, you need to deploy the TI. And the scenario, an analyst get an alert with flagged IP, but context says it is 6 month old. How do you handle stale threat intel? So you can discuss the TI scoring, TTL of IOCs, and the source reputation weighting, and not auto blocking based on low confidence or old indicators. So this is how you can handle this scenario. And the pro tip is MISP Open CTI are very popular open source TI platforms. So when you are answering your question related to TI, you can mention you have integrated MISP TI integration or MISP TI platform with your SIEM, and you are getting regularly TI feeds. So by mentioning you have integrated STIX and TXI protocol or built a custom lookup pipeline shows hands-on experience. Next question we have: what are the most critical log source to onboard first in your SIEM deployment? This is very good question. So you can prioritize by coverage the value like Active Directory and identity, because identity is very important, like who is logged in, from where logged in, when logged in. So these activities are very important from authentication and identity perspective. And most of the incidents are evolve the password or credential related attacks. So these are the very important one: Active Directory and identity. Then the second one is firewall and network security groups. So you will get a full network visibility, what's coming, what's going within your network or outbound traffic, and what kind of attacks you are getting on your network side. So you will get a full visibility of it. Then the third one is EDR and AV logs. So this is going to cover your full endpoint telemetry, like what is happening on your end user computer, whether user is downloading any unwanted applications or software, or doing any suspicious activities like connecting to Tor or creating some suspicious script. So you will get a full visibility of it. Then VPN and remote access. So this is also very important from the identity and authentication perspective. And then the DNS. So it's a massive detection signal. Almost all malware uses DNS, so you can get the DNS callback activity and uh, some DNS abuse, and also DNS is also very important. And then web proxy and email gateway. So web proxy and email gateway will help you to identify the phishing related activity and social engineering related activity in your environment. And then cloud platform log like AWS CloudTrail, Azure audit logs. So if you're using cloud in your environment, then it is needed to ingest, because cloud have a lot of misconfigurations, and also you can understand the pattern what is happening on your cloud. So get these seven right and you cover 80% of your attack surface. So you can make a note of it. You can ingest your AD, your identity, and number two, the firewall and NSG. Number three, you can add the EDR AB. Number four, VPN. Number five, DNS. Number six, web proxy and email gateway. Number seven, cloud logs. So this is going to cover your 80%. And the scenario here we only have budget to onboard three log sources right now. Which ones? So you can mention the Active Directory, firewall, DNS. So these are important from attack perspective and SOC perspective. So you can detect a huge portion of the kill chain with just these three. And the pro tip here is answering these questions with a ranked list plus justification signals that you think risk based, not just technically. So junior candidate list everything and senior candidate prioritize. So if you know which logs are very important from ingestion perspective, this will definitely boost your chance to get selected in the interview. All right, so the next question we have, what is the use case in the context of SIEM and how do you build one from scratch? So a SIEM use case is a documented detection scenario with a defined log sources, correlation logic, alert threshold, triaging steps, and response action. So you can build a use case using these steps. So number one, identify the threat. So you need to identify what exactly you wanted to detect. Easy, like brute force against Office 365, and then map your rule with MITRE technique. So you can map the brute force with T1110, and then identify the required log source. Like you are going to target the Azure AD sign-in logs, and then write the detection logic. So if you're using Splunk, you can use the SPL to write the logic. If you're using Sentinel, you can use the KQL to write the logic. Then test with synthetic or replayed attack data. So you can simulate your attack and test your logic, and then set threshold to minimize false positive. So this will help you to minimize the false positive and get the real attack. And then number seven, uh, write the triage playbook. So how you are going to triage this use case and alert. Then you can do the peer review and push to production with monitoring. So these are the steps you can follow to write a use case in SIEM. And we have a scenario here. We have just migrated to M365. What is the first use case you would build? So you can build the impossible travel and risky sign in and alert when the same user authenticates from two geographically impossible locations within a time window that cannot be explained by time travel. So suppose there is a user who logged in at 10 a.m. from Australia and again logged in at 10:05 a.m. from Russia. So this is an impossible travel risky sign in behavior. And the pro tip here is the best use case answers follow the threat, data, detection, and response. So this structure shows you think end to end, not just about writing a query. All right, the next question is what is SOAR and how does it relate to SIEM? So SOAR, security orchestration, automation, and response. Automate the response side of what SIEM detect. So here is your SIEM, and you can deploy a SOAR here. So if SIEM detecting any alert, SOAR can respond on it automatically. So SIEM equal to detect an alert, but the SOAR equal to automatically respond on the detected attack. So when your SIEM fire a phishing alert, SOAR can auto pull the email, check the attachment in a sandbox, query threat intel on the sender domain, block the sender, and open a ticket, all without human intervention. And there are some well platform like Splunk, SOAR, which is earlier known as Phantom, Palo Alto XOR, Microsoft Sentinel Playbooks, which is known as Logic App, and Swimlane. So SOAR can take automatically action for you, like detecting the phishing email and then pulling the email, blocking the sender, getting the attachment in a sandbox, analyze them, and provide a report and create a ticket. So here we have a scenario. Your L1 team is overwhelmed with alert. How do you help? So the SOAR is the answer here. Build playbook for top 5 high volume, low volume complexity alert types and automate the repetitive tasks like enrichment, like IP enrichment in the virus total, and the initial triage like running some KQL or SPL query and getting the results. So the analyst focus on decision, not data gathering. And the pro tip here is know the difference between automation and orchestration. So automation is like a no human intervention, and orchestration is like a coordinating multiple tool with optional human approval steps. So orchestration include all your connectors, your data connectors and integrations. So SOAR does both. SOAR have orchestration plus automation. Next question is, explain the concept of data retention in SIEM. What is typical policy? So a data retention define how long log are kept and at what accessibility tier. So data retention is required to fulfill your compliance need. So I saw many client retain their data for 7 year, and some client retain their data for 1 year only. So it is based on compliance and your requirement, and there are typical policies you can follow, like hot storage. So this is immediately queryable, so you can query your data for 30 days or 90 days. So this is online data that you are ingesting now. It will be available for 30 days and 90 days. And then warm storage, so queryable but slower. So you can query your data for 90 days to 1 year, but this will be slow because this will be in different tier. And then the cold storage, so these datas are archived and the retrievals are very slow. As I mentioned, you can retain it for 1 to 7 year, and the retention requirement are driven by compliance. So yeah, compliance is the one because of the retention is needed. So there are many compliance like PCI DSS require 1 year, HIPAA varies, NIST require 3 year data retention, and the cost is constant here because the hard storage is very expensive because it is stored on SSD and memory, but the cold is cheap because this is a glacier data and S3 bucket data and tape data. So choose your data retention wisely to save some money and cost. And the scenario here is a breach is discovered and a attacker was in your environment for 14 months. Your SIEM only keeps 90 days hot data. What do you do? So you can retrieve data from cold storage, and this is why the tiered retention exists. So this will save the cost and also your requirement. And the pro tip here is compliance drive retentions minimums, but threat hunting drive the ideal. So the longer you keep queryable data, the better your chance to retroactively detecting long dual attacks. But again, keep it in mind because data retention required a lot of money and cost. All right. So the next question is, what is the CIA triad and how does it relate to C monitoring? So CIA equal to confidentiality, integrity, and availability. So this is the CIA triad, CIA. So in C monitoring maps directly, confidentiality is like a violations of unauthorized access, data exfiltrations, privilege escalation alerts. So you can map these alerts with confidentiality. And then integrity violations means file modification, configuration change, log tampering, alert on gaps in log ingestion or deleted audit log. So that fall under integrity. And then availability violations means DDoS detection, service outage correlation, ransomware precursors, the rapid file encryption activities and all. And your detection use cases should map to at least one CIA component. So this is how you can map your alerts with CIA triad. And the scenario we have, how do you detect a ransomware precursor in your SIEM before encryption start? So you can create alert for availability integrity focused, like mass file read. It is staging for exfiltration, so your staging start for exfiltration from mass file read. And then shadow copy deletions, so volume shadow copy deletions, unusual process created modified thousands of files. So this is another sign of ransomware encryption activities. And then the lateral movement towards backup system. So if you see a server logged in on multiple systems and then it is going to a backup server, then this is a sign of ransomware precursor. So this is how you can map all these alerts in SIEM and achieve the CIA triad. And the pro tips here is, CIA triad questions are common, at the start of the interview to assess fundamental. So it's a very fundamental question. And if you are preparing for SOC interview or getting into IT security, you will see this question as a fundamental point. So at the beginning, you need to learn the CIA triad, but mapping the CIA triad to SIEM is little different. Here you need to map all the rules or your logics or the detection engineering part with CIA triad. So nail this, then optionally extend to NIST and CSF, like identify, protect, detect, respond, and recover, the whole life cycle for incident response to so broader framework knowledge. All right, the next question is, describe the high level architecture of a SIEM and what are the core components. So the core components in the SIEM are log collector layer. So log collector and the function of the log collectors are like agents. So if you work in Splunk, you need to deploy the universal forwarder agent to systems and elastic agent, the file beat agent, or if you are using any agentless integrations between systems, so you can use API polling or syslog. So syslog work on 514 UDP or TCP, that you can decide. So this is how you can work with agentless systems. And then the second layer is data pipeline. So data pipeline do all the parsing, normalization, enrichment, and the filtering of the logs. So the first part is collecting the data, collect, then normalization. And normalizations and enrichment and parsing can be achieved through a data pipeline. And then storage layer, so you can store your log for query or retention or backup, like hot, warm, cold tiers, and the indexed search. So here you can map and store all your data, so storage. And then the fourth layer we have correlation engine. So here you can connect the dot and correlate the data with various data sources and create rules. And then UEBA also work here in the correlation engine. Then we have the alerting part where you can alert and create some case for your triggered alert or triggered incident, and then send it to ticketing, and also the reporting and dashboard part for compliance requirement or SOC metrics. And then also we have a threat intel integrations to looking up the enrichment. So this is a very high level architecture, and this is a in general architecture, not a tool specific like a Splunk or Sentinel. And the scenario here we have, we need to ingest log from 10,000 endpoints without killing our central SIEM. How do you architect that? So this is very good question. So you can use the distributed forwarders and then the regional aggregators and the central indexers, ingestion pipelines, and you can do the load balancing, then compression, and then filter at the edge. So I can draw an architecture. You can use the universal forwarder architecture or Happy forwarder, then collect the log from various regions using aggregations, like you collect log from one site, site 1, site 2, site 3, and then send it to Happy forwarder. And from there you can use the central indexer. So this is your index, and here you can search the data. And then if you have a lot of loads, you can do the load balancing. You can deploy another forwarder here, and then you can distribute the logs, or you can create a DR site for the disaster recovery and map with universal forwarder, I mean the Happy forwarder. And then you can filter the log at the edge. So here you can do all the filtering. And the pro tip here is, draw this as a diagram in your head during interviews, and being able to verbally walk through the architecture like you are pointing at the whiteboard impression senior interviews. So you can take a note of it in your notebook, and if you go in interview, describe it step by step and talk about the each blocks of the architecture. Then this shows maturity. All right, next question we have, what is the difference between agent based and agentless log collection? So agent based log collection is a software agent that run. So suppose you have a Windows machine, then you need to deploy a agent here. So if you deploy the agent, it will send all the data in real time to the central brain of the SOC, like your SIEM system. So a software agent run on the source system, like this universal forwarder. So Splunk have universal forwarder, Elastic have agent, and there is an Xlog. So the pros of this, it's reliable delivery. So there will be no issues. If you deploy the agent, you can monitor the individual systems, and if any failure, then you can upgrade or troubleshoot the universal forwarder. And local buffering, so you will get the local buffering advantage in real time. I mean, you will get the log in real time, and you can collect any files. And the cons, so cons is like deployment overhead, because you need to deploy universal forwarder on every systems. So suppose you have 10,000 system, then it will be very hectic work to deploy universal forwarder on 10,000 machines. And then maintenance part, then you need to maintain the version, the patches for these servers. So the maintenance problem will be there, and not possible on some devices like OT or legacy systems or network gears. So if you have network devices or some OT systems where the internet is not available, then it will be challenging in that environment. And what is agentless? So agentless log collections based on source process. So like you can, if you have syslog servers, uh, so suppose you have the multiple Linux server, you can forward those log using syslog forwarding model to a single server. And you need to create a server here which is called as syslog server, and then syslog server can pull log to your SIEM system. So it can use the syslog method, which is 514 port number, and snmp trap. And there is another method for agentless. SIEM can do the API polling. So you can do the API polling directly with the application or device, or using Windows Event Forwarder. So Windows Event Forwarder is a policy based log forwarding for Windows machine, where you can forward log from multiple systems directly using domain controller to a SIEM system. There you need to define some policy and also define the log you are going to collect. So this is how we can do the collection using agent based and agentless. And the pros of the agentless connections is no software deployment is needed, but the cons is like it's a potential gaps, and the UDP syslog unreliability and no buffering. So these are the disadvantages. In the scenario we have, we need to collect log from 500 Cisco ASA device, which is a firewall device or switches. Agent or agentless? So we would say agentless, because Cisco devices supports syslog, so we can go agentless using syslog model, which is a standard model for networking device. So you can go in the master uh, console and forward the log using 415.514 and using the IP addresses to your SIEM system. And also you would configure the ASA to forward the syslog collector aggregator, then forward to SIEM. And the pro tip here is, in the real world, most environment use both agents and agentless. So agent is for Windows and Linux endpoint, and agentless is for the networking device and cloud APIs. So use both agent and agentless. So saying this shows you know practical experience and you have like knowledge to deploy the SIEM and log sources. All right, the next one we have, how would you design a SIEM architecture for a hybrid cloud environment like on-prem plus AWS plus Azure? So for the on-prem, we can deploy the forwarder agent on the endpoint. So on-prem, we can deploy the agent like universal forwarder and then aggregate via syslog collectors. So universal forwarder directly send log to your SIEM system, and syslog method will have a dedicated syslog server where you send log from various systems and then it will forward log to the same. And for the AWS, you can send log using CloudTrail. So suppose this is your AWS. So you can use the inbuilt services like CloudTrail or BPC flow log. So this collect all the network traffic and the activity log and the guard duty. So guard duty, another one, is like it collect all the security data on AWS side. So guard duty is another option. So you can send these finding via Kinesis, then Lambda, and then CM API or S3 bucket polling. So here is the whole process. Like you can use the S3, you can use the Lambda, you can use the Kinesis. There are multiple methods you can utilize and send log to SIM. Then if we talk about the Azure, so as we use the CloudTrail VPC guard duty, in the Azure side we can use the same. So for Azure we can use Azure Monitor. Azure Monitor collect all the Azure related log, and then Event Hub. So Event Hub is another good tool that you can forward. There you can forward logs to like native Sentinel connector or custom indicator. So you can send log to your SIEM directly. And the key challenges are here: latency, data residency, and volume spike for cloud. So these are the challenges, and we can use a cloud native SIEM like Sentinel or Chronicle, or a scalable indexing tier like Elastic or EKS to handle cloud volume economics. So these are the options we can utilize. And the scenario here, we have our SIEM bill tripled after migrating to AWS because of log volume. How do you fix it? So we can filter at the source and only ingest high volume, high value logs. So high value logs are like your guard duty or some activity related log like CloudTrail log. So these are the high value logs we can collect and use S3 based cold storage. So you can use the cold storage at your S3 bucket size, and you can also use the cold storage for bulk log with selective query on demand, and right size log verbosity for per source. So if you are ingesting anything, you need to understand what you are ingesting and why you are ingesting. So the log you are ingesting should have some business use case. And the pro tip is hybrid is the dominant architecture in 2025 or 2026, and showing you have thought about data gravity, cost. Log routing in multi-cloud environment is a major differentiator. All right, question 19. What is a log aggregator or syslog relay, and when would you use one? So a log aggregator like syslog relay, concentrator, sit between log source and the same. So this is your syslog relay. This is your data source, one system, two system, three systems, and then you can send log to your syslog server, and this will forward log to your SIEM. So this sit between log source and the SIEM, and it collect all the raw log, then perform the initial parsing, filtering, buffers during SIEM outage, and forward to SIEM. So this do all these activities like parsing, filtering, and collecting all the raw log, then forwarding it to SIEM. And the tool like rsyslog, syslog ng, logstash, Fluentd, and the Cribl stream. So these are well-known data pipeline and log aggregation tools. So if you understand the configuration or configuring of these tools, you are going to rock your interview. And the use cases, so high volume sources like your network gear flooding SIEM, and sources that cannot send the SIEM directly. So where exactly you can use these tools? So you can use for the high volume sources like your network gear, which always flood the SIEM, and the sources that cannot send log directly to SIEM, and some network segmentation logs like DMJ sources routing through some aggregators. So This is where you can utilize these tool and also pre-filtering to reduce SIEM license cost. So in the aggregator side, you can do all the filtering and cleaning of your data, then you can send it to SIEM, and it will save your cost. And the scenario we have a factory floor of OT devices that can only send UDP syslog. Our SIEM is in cloud. How do you connect them? Very good question. So you can use the on-prem aggregator in your OT and DMG to receiving the syslog and then reformat it and then forward it to over TCP and TLS in the cloud SIEM ingestion. So you can, this is your OT environment. You can deploy the aggregator here in between syslog and send all the log to that syslog. And from there, you can send the log directly to your cloud native SIEM using TLS and TCP. And the pro tip, Cribl has become the industry standard log aggregator router. So if you are familiar with it, mention it. It is real differentiator in the interview right now. So if you know the Cribl, Cribl is a data pipeline aggregator and forwarder tool. So you need to understand the Cribl. All right. So what is index design and why does it matter for SIEM performance? So index design determine how data is stored. So every data go to indexers. So if you send any data using universal forwarder or heavy forwarder, it will go to specific indexer. So like if you're sending Windows log, it will go to index win event. If you're sending Linux log, then it will go to some different index like Linux index. And if you're sending network log or firewall log, then it will go to index equal to pan log. So this is how the index store the data, and this is help in storage, searching capability, and the retrieving the data. And the poor indexing will cause slow queries and high storage cost. So the key decision you can make while designing the index, you can use the field extraction at index versus search time. So index time is faster but less flexible. Index granularity, so one big index versus per source indexing will help you to like separating high volume source and improve the search performance. So instead of going one big index, you can distribute your index uh, with multiple sources by volume, and this will improve your search performance. Then the bloom filter, so for fast field lookup you can use the bloom filters. And then the timestamp alignment, so you can ensure that event time matches index time to avoid search window misses. And the compression, so 5 to 10x reduction is typical when you're using the compression. And the scenario here we have in Splunk term, putting in point log and network log in the same index at 500 GB per day means every search scans both. So you can separate the index plus correct source and source type, and the tagging will save you 10% cost or 10% faster searches. So it is basically saying if you have Windows log, keep it separate, send it to Windows indexer. If you have networking log, then you can separate the networking log. So if I say networking log, that mean in networking also you have many devices, right? Like firewall, proxy. So you can keep everything separate with separate indexer. And pro tip here is, this is a senior level question. For junior and mid role, just knowing why index design matter. It matter because it increase the search performance, it decrease the cost and the data isolation. So this is enough as a junior engineer. But if you're senior, then you know the how to do the index design and what are the mechanism behind it. All right. All right, question number 21. What is a data pipeline in SIEM context and what tool sit in it? So a data pipeline is everything between log generated and log queryable in SIEM. So that means this is your log source. There are multiple systems, and then there is a pipeline, the complete pipeline where all the like parsing and then normalization and then filtering, enrichment happens between your SIEM system and your log sources, and then it is sending the data to SIEM system. So you can see here that data pipeline is everything between log generated and log queryable in SIEM, like log collection, transport of the log, then parsing of the data, then log normalization, and enrichment of the data, then filtering, storage. So a tool at each stage, it collect log like using some elastic agent, universal forwarder agent, or filebeat agent, and then transport the data like using Kafka, can say syslog, and then transform the data like Logstash, Cribl, AWS Lambda, and storage like Elastic Storage, Splunk Indexer, Chronicle, Azure ADX, and then it is also adding the enrichment inline. So modern pipelines add the enrichment inline, like tagging event with asset info, geo IPs, and threat intel before storage. So if you heard the tool called Cribl, Cribl is already doing these activities. So it is doing the auto indexing as well. So no need to design your indexers. The pipeline is doing collection of the log and then transport of the log, then parsing and enrichment, and then filtering, and also the storage part. So this is exactly the pipeline. And the scenario here, we have an event is generated on Windows endpoint. Walk me through every hop until it appears in a SIEM dashboard. So we can mention the sysmon event, whether the event is collecting using sysmon agent or any universal forwarder agent or sysmon agent. And then you can mention the elastic agent reads the window event log, then forward it to Logstash. So Logstash is another aggregator tool which parse the log, normalize the log, enrich the geo IP and all, then index into the Elasticsearch. And then you can use the Kibana to create your dashboard and visualize the data. Knowing your pipeline code is a tier 2 or detection engineer job, and it is must for them. And being able to walk through the data flow from source to dashboard impresses even senior interviewers. All right, next question we have: what is high availability, the HA, for SIEM, and why does it matter? So high availability, the HA means the SIEM says operational if component fail and no single point of failure. So this ensures the availability. Ensures availability. So typically this achieved via clustered indexers and data nodes, and the data replicated across nodes, and the load balance ingestion endpoint, search head clustering, and the multiple query nodes deployment, and redundant network path for log forwarding. So these are the options you must follow while you are designing your SIEM, because high availability is very important in your SIEM perspective. Because if you lose your data, then you will lose your compliance, lose the visibility against threat. If SIEM log goes down during an active breach, you are blind. So that's why it is very important. And high availability, the HA also support zero downtime upgrade and maintenance window. So not only during the compliance or visibility on your threat, this is also help when you do some upgrade of your components like universal forwarder, or if you are upgrading your syslog device, then it is going to help you. And SOC SLAs often require 99.9 uptime, right? And the scenario here we have, our SIEM was down for 6 hours during a ransomware incident because the storage node crashed. How do you prevent this for future? So you can raid or replicate indexers. You can cluster the architecture, alerting on the ingestion gap. So if any log is down for 1 hour or 30 minutes based on your requirement, you can immediately send an alert to your detection engineers and backup log buffers at the forwarder labels. So this will help you to maintain your HA. And the pro tip here is most enterprises run Splunk or Sentinel. No high availability concept for at least like Splunk equal to indexer clustering plus search head clustering, and Sentinel have their built on Azure, so it inherits Azure regional redundancy. So if you're using cloud native SIEM, you need not to worry about it. But yeah, while collecting the log, you need to take care some of the components high availability. All right, next we have the question number 23. What is the difference between on-prem SIEM, cloud native SIEM, and hybrid SIEM? So on-prem SIEM, you have full control of your SIEM, like data will stay in your DC, your domain controller, in your servers. This is very expensive because infrastructure and maintenance will be done by your team. So you require a lot of experienced candidate to maintain and maintain the SIEM and infrastructure. And this scales with hardware. So if you want to index 100 more GB data, you need to apply some additional hardware, right? So hardware come with cost. So this is very expensive. And for example, if you're using enterprise Splunk or IBM QRadar, so these are the on-prem, and ArcSight ESM is also on-prem. And the cloud native SIEM, so it is a vendor managed infra. So you are going to only take care of your integration part and then content development part, but the infrastructure and maintenance will be taken care by your vendor like Azure or AWS or GCP, where your SIEM is deployed. So this is elastic scaling. So suppose you are ingesting 500 GB data per day, and you integrated 50 more server and you got 100 GB data increase. So this will automatically increase. It will shift your license or storage to 600 GB per day without any uh, any challenge. So this is consumption based pricing. So suppose you are ingesting 600 GB data for today, and tomorrow you are going to ingest only 300 GB, then you need to pay only for 300 GB for tomorrow, not the complete 600 GB, even if you have the license for 600 GB per day. So this is better for cloud heavy environment. So if your business works on cloud and your most applications deployed on cloud and you are a cloud native company, then you can go for uh, cloud native SIEM multi-cloud. So here are some examples like Microsoft Sentinel, Google Chronicle, Elastic SIEM on Elastic Cloud. So these offers the cloud native SIEM solutions. And then we have hybrid model. So SIEM infrastructure span on-prem and cloud both. So it's a kind of mixture of on-prem and cloud, and the common migration path for the data residency requirement. So you can either uh, store your data on cloud, or you can put it on a server hardware at your environment. For example, Splunk cloud with on-prem heavy forwarders. So this is a good example of hybrid cloud SIEM. And the pro tip here is in 2026, the market is clearly moving to cloud native. So because now the business also moving on the cloud. So yeah, cloud native SIEM is uh, most popular nowadays. So tools like Chronicle and Sentinel are growing very fast. So Sentinel started in 2019, but they are the biggest competitor of Splunk. But the Splunk is still boss of SIEM. And knowing their pricing model and trade-off versus Splunk is a genuine competitive advantage in interview. All right, 24th. How do you handle log source onboarding at scale? Walk through your process. So the structured onboarding include the discovery. So you can discover your inventory, what the log sources are, what are the format of the log sources, then volume, then transport protocol. So you need to do a complete assessment on your environment and the data sources that you are going to ingest. Then parsing capability. So write, find a parser and test against the sample logs. So collect some sample log from various categories for your source, and then write a parser for it and test against the sample log. And then the normalization. So map your field to common schema like CIM or ECS, and then this will help you to create some use case or enrichment. And then the next one is enrichment. Add your asset data, geo IP, threat intel, so enrich with all the available information. And then the testing part. So replay sample events and verify the field extraction. So if something is not parsed or field is not extracted, then you can fix it. Then use case validation. So confirm existing detection rule, fire correctly on new source data. And then documentation. So you can document all your sources, your log format, parser, honor, SLA. And then the next part is monitoring. So alert on the ingestion gaps or format changes. So this will help you to keep an eye on your infrastructure and log mechanism. Then pro tip is having a log source onboarding run book is sign of a mature SOC. So if you have a run book for your log sources that you onboarded, then your SOC is very mature. And mention that you would document it and peer review the parser before pushing to the production. All right, so what is a forwarder and how does it differ from syslog agent? So a forwarder like Splunk Universal Forwarder, Elastic Agent is an intelligent agent that monitor file APIs and then buffer data and then compress and send reliably to SIEM with acknowledgement. So this work on your source side and send the log source to your SIEM system. But the syslog agent is simpler. It captures the syslog messages and forward them. And this is offer over UDP protocols. And the key differences are forwarders have local buffering and there will be no data loss during SIEM outage. And it also support multiple output destinations and can do local filtering, masking, and have agent management capabilities, while syslog is very lightweight and it's a standard for network gear. So if you're using networking related logs or log sources like firewall, proxy, your VPNs, then syslog is better option. But if you have like uh, heavy forwarding from Windows machine or some Linux machine you have, you can use the universal forwarder or some other forwarder. And the pro tip here is knowing which tool to use for which source is practical knowledge interviewers love. So it shows you actually built pipeline, not just read about them. All right. So question 26, how do you write a detection rule for a brute force attack against RDP? So the logic you can see here, we can start with the source type, and the source type is Windows security because RDP is part of Windows and all the activity will log to the Windows security only. So we can start with Windows security. Then the event code 4625, which is for failed login on Windows, and then logon type 10, which is for uh, remote login or interactive login, and then state count by source IP, destination host, and user. And then where count is greater than 20 in 5 minutes, then alert. So this is a logic. So you can break it down. So event code 4625 is for failed logon, and then logon type is 10, which is for the remote interactive, the RDP, and you can group it by source IP that catches the distributed spraying, and grouping the user which catches the password stuffing. And you can mention the threshold 20 in 5 minutes is tunable. You can start low, you can start with 10 in 5 minutes, then you can tune it for 20 based on your environment and baseline. And also you can add a filter to exclude known monitoring scanning tools. So if you deployed any tool like Qualys, Nessus, and they are scanning your systems, then you can whitelist it. So scenario here we have your brute force rule, fire 200 time in a day, but 190 are a vulnerability scanner doing RDP check. So fix it. So you can add an exception in your rule for the scanner's IP, and also you can add a asset tag by checking if source IP is tagged as vulnerability scanner, then suppress. So you will get the 10 actual attacks, and you will eliminate the 190 events. And the pro tip here is always show the interviewer you think about both side, the detection logic and tuning side. A rule with no tuning story is incomplete. All right, so the next we have, what are some key Windows ID every SIEM analyst should know? So here we have some key event Windows IDs. So number one, 4624. So 4624 is for your successful login, like your authentication success on Windows machine. Then 4625 for failed login, and 4648 for login with explicit credentials like pass the hash indicators. And then 4688 is very important. So this is for process creation. All the new process creation can be detected using 4688 with command line login is a goal here. And then 4698 and 4702. So this is for scheduled task created or modified. So this is another good one from SOC perspective. And then 4720 for user account created, and 4732 for member added to security enabled local group. So 4720 and 4732 both are good from audit perspective, but also you can map it or correlate with the bigger picture. And then 7045 for new service installed on the computer, 4776 for NTLM authentication attempt, 4769 for Kerberos service ticket request, like Kerberoasting indicators. So tips is memorize at least the top 10 and print them, put them on a card. So in interview, you are being able to say 4688 with command line logging enable is where you can catch the most in memory attack. So this is kind of a specific answer that Lands offers. All right, how would you detect pass the hash in a SIEM? So a pass the hash is when an attacker using NTLM hash instead of password to authenticate, and the SIEM detection signals you can include. You can use the event code 4648, which is for the login or log on with explicit credentials from unusual sources. Then you can use the event code 4624 and then log on type 3 for network log on with NTLM SSP authentication from the account that normalize uses Kerberos. And also you can look for the lateral movement pattern, the same user multiple destination in short time. So if a user A login on three different systems in 2 minutes, this is lateral movement. And authentication from non-domain process, mismatched workstation name in 4624 versus actual source IP correlation with 4776, the NTLM authentication from an account that should only use Kerberos. So this is how you can answer or create the pass the hash detection in SIEM. And the scenario we have, so we see a service account authenticating via NTLM to 12 different server in 3 minutes. Is this a pass the hash? So the strong indicator says the service account should authenticate predictably to a small set of destination, but it is uh, like going to the 12 different servers. So yeah, it's a indicator of pass the hash. This pattern combined with a recent suspicious process on the source host. So this is an incident. And the pro tip is pass the hash is a classic lateral movement technique. So tie this with MITRE ID 1550002, the subtechnic ID in your answer, and this shows the framework thinking. All right, describe how would you detect Kerberoasting attack in your SIEM. So a Kerberoasting is a request for the Kerberos service. So Kerberoasting is like requesting Kerberos ticket. The TGS tickets for a service account, then cracking them offline. So detection via event code 4769, you can detect it, and you can use the RC4 encryption type like 0 multiply 17. So this is a weak crypto sign, and choose for online cracking speed. So if you see this code in your log, that means this is like weak crypto. And the pattern says same user requesting many 4769 event with RC4 in short time, the service account they don't normally access. So the baseline normal TGT request rates per user, and also look for unusual service principal name, the SPN being enumerated via LDAP query like 4662 via LDAP queries. So the pro tip here is follow up with to prevent Kerberoasting using AES 256 encryption for service account, and consider managed service account. You can give a prevention for long time along with detection shows maturity. All right, question 30. How do you detect data exfiltration in a SIEM? So you can utilize the multiple signals to correlate, like the volume anomaly, like outbound data transfer significantly above baseline for a user or endpoint. So suppose there is a user or endpoint which starts sending large volume of data to a third party applications or website like 5 GB data. So it's a volume anomaly for them. And then DNS. So DNS tunneling like high volume TXT records or queries, long subdomains, and query to newly registered domains. So if you see these signs, that mean it's a data exfiltration. And protocol anomaly. So data leaving on unusual ports like STTP on port 8080 or FTP on 2121. So these could be a sign of data exfiltration. And then time anomaly. So this large transfer happening at 3 a.m. So this is another sign of data exfiltration. So suppose a large transfer at 3 a.m. for an account that normally works from 9 to 5. And then destination. So if the data is going to a file sharing site or a paste site like a paste bin or cloud storage that is not approved by your IT, so it's a clear sign of data exfiltration. And also the DLP integration. So DLP events correlate with SIEM authentication context. So DLP event can provide more detail on the user's activity, like what kind of activity they are performing or what data they are transferring. So the scenario is an employee is leaving next Friday. How do you monitor for insider data exfiltration this week? So you can monitor the large email attachment. So if email attachment with going 35 MB or 5 MB or 10 MB, so this could be an insider data exfiltration. And then USB write. So you can monitor 6416 Windows event for USB write monitoring, and then cloud sync client upload to personal account like your Gmail, Dropbox, or any other account where the user is syncing and transferring the data, and mass file access on file share. So these all are the sign of data exfiltration. And the pro tip here is data exfiltration is chronically undetected. And mentioning DNS as an exfil channel, most organizations allow outbound DNS freely. So this shows advanced thinking. What is a detection rule lifecycle and how do you manage rule over time? So the lifecycle include idea, research, development, testing, peer review, staging, production, monitoring, tuning, and then retirement. So most team fail at the monitoring and tuning phase because they have no clear run book or playbook to monitor and tune the data, and rule get written and never revisited. So if you're writing any rule, you need to regularly review it. So the best practice is quarterly review of all production rule and the metrics per rule like alert volume, true positive rate, false positive rate, analyst time to close, then retire or rebuild rule that have not fired in 6 months or have 5% or I mean lower than 5% true positive rate. So user detection as code approach and rules in Git for version control. So modern SIEM allow you to manage your rule through Git or GitHub or Content Hub. And modern SIEM comes with rule comparison as well for tuning. So the tips is detection as code like Sigma rule, YML based rules and repository, CI/CD pipeline for detection is a hot topic nowadays. So if you are preparing or working as a detection engineer, you must understand these points and mention it, and it will show that you are current and it is future of detection engineering. All right, next, what is Sigma and how it is useful in SIEM operations? So Sigma is an open source vendor neutral rule format. So it's a common rule format which can be used by any vendor. So it's a vendor neutral. So it's a vendor So it's a vendor neutral rule format for SIEM detection logic. So you can write a rule once in Sigma YML format and then use it for like Sigma converter or Pi Sigma to compile it with your SPL, EQL, KQL, AQL, etc. So Sigma rule can be translated into KQL, SPL, AQL, EQL, or any other rule. So the benefit here is write once and deploy anywhere. So like you can create your rule as a detection engineer and deploy it anywhere. So this is often useful when you are working in MSSP environment and you have multiple SIEM tool uh, for various customers like Splunk, QRadar, and Sentinel. So the community sourced rule like Sigma HQ has 3000 plus rule and you can utilize it. And the version control in Git. So Sigma have version control, and if you change anything, then it will come with a version and vendor independent. So you can choose any vendor if you are writing your rule in Sigma. And it's a huge time saver for teams running multiple SIEMs or migrating between them. So if you have a Sigma rule in YML format and you are migrating from QRadar to Sentinel, then you can convert all those rules into Sentinel easily. So you will not lose your existing detection engineering part. So the tip is saying I use Sigma to write vendor agnostic detection rule and maintain them in Git is extremely impressive and shows you are operating at a detection engineering level. Then the next we have how would you detect a living off the land, the lol bin attack in a SIEM. So a LOTL attack uses built-in Windows tool like PowerShell, WMI, certutil, MSHTA, Reg Saver 32 to avoid any detection. And the SIEM signals 4688 events showing unusual parent-child process relationship between Word, spawning PowerShell or Explorer.exe running MSHTA and PowerShell script block logging event code 474104. So look for the encoded command dot string and then base 64 string download cradles IEX net web client WMI persistence, and these are the codes that you can monitor for WMI and the certutil downloading file. So these are the patterns that you can follow to monitor the living of the land attack. And also you can correlate with parent child anomalies. And the scenario defender says no malware found, EDR says PowerShell run with an encoded command. Is this a concern? Yes, definitely it is a concern. You can pull the 4104 event and decode it, the base 64 format, and look for the download cradles or suspicious commandlet. So this is a classic land of the living attack staging behavior. And the pro tip here is PowerShell script block logging like 4104 and module logging 4103 are essential for catching living of the land attack. So if your environment doesn't have these enabled, it is a detection gap worth calling out. All right, so what is threat hunting and how does it differ from alert based detection? So an alert based detection is reactive defense of security. So if SIEM trigger an alert or fire an alert, then analyst can investigate. And it is relies on the known bad pattern. So you have a rule, you have some sample of the logic or query, and you are rely on the query and rule. So if the alert fires, then you can react on it. But the threat hunting on other side is a proactive defense. So analyst is going to hypothesizes about how an attacker might be in the environment and goes looking even without an alert. So there will be no alert and you are going to approach the threat hunting. So you will pick a MITRE technique or kill chain, and then you are going to dig deeper and find all the possible attack scenario or pattern in the log. So this is what the threat hunting is. So the example hypothesis here is an attacker using Cobalt Strike. So Cobalt Strike is a well-known red teaming tool and would have weakening traffic at regular interview or intervals on a non-corporate domain. So the hunter queries beacon-like pattern in proxy log and find the host, confirm the compromise. So hunting find things that no rule detected. It then generate new rule for the future. So the approach is you create a hunting query, threat hunting, and if you find something, just convert it into use case. So this is how you can automate it for next time. And the tip is frame threat hunting as the feedback loop for detection engineering, and every hunt that finds something should end in a new or improved SIEM rule. So interviewers love this closed loop thinking. How do you detect privilege escalation in SIEM? So the key signals are event ID 4672. That means the special privilege assigned to a new logon that indicate the admin equivalent right is being used, and the event code is 4648 is for the logon using explicit credential. So this is a process requesting elevated right. And then also we have code 47283256. So this is for the user added to a privileged group like domain admin or administrator or backup operator. So the process command line showing who am I privilege, net local group administrators, and taken manipulation like SE debug privilege. So correlate with them with MITRE technique like T1068. That's for the exploitation for privilege escalation, unusual process elevation via known exploit. And the pro tip is atomic red team, the art Red Canary has test cases, so you can simulate your test cases using MITRE technique, and mentioning that you test your detection coverage with Atomic Red Team test shows hands-on experience. So you can deploy Red Canary on a test system. So it's a complete PowerShell based module, and you can simulate the attack and generate an alert in SIEM. All right, next one. What is a watch list or suppression list in a SIEM, and when do you use each? So, a watch list or reference list is a set of known entities like your VIP users to monitor extra closely, high risk IPs to alert on any activity, or new employees in their first 30 days. So, this list can be used to increase sensitivity for specific target. So, a watch list could be a CSV file or list directly can be saved in SIEM. So you can create a blacklist, you can create a lookup, or you can create a whitelist for your entities using watch list. So these three are the major role of watch list. And a suppression list is the opposite. It's a known good entities to exclude from alert, like your vulnerability scanner, monitoring server, jump boxes, service account with predictable behavior. So using suppression list, you can reduce your false positive without weakening the rule logic itself. And you can review the suppression list quarterly and stale suppression hide real attacks. So watch list can blacklist or lookup table or whitelist your entities, where the suppression list purely focus on suppressing the entities. Suppress entities like IP, user, or your scanner device, etc. And also you can suppress your alert which you don't want to see in the analyst queue. The pro tips here is suppression is not the same as disabling a rule. Always suppress specific documented exceptions rather than lowering threshold, and always timestamp suppression with an expiry review date. So either whitelisting directly in your rule, you can always use a suppression list. All right, so the next we have what is EDR XDR integration with SIEM and what value does it add. So EDR and XDR is a endpoint protection platform for your servers and for your end user devices like host or laptop computers. So EDR tools like CrowdStrike, Falcon, Sentinel-1, MS Defender for endpoint provide a deep endpoint telemetry like your process tree, memory events, networking connections from the endpoint or servers, and XDR extend this across network, cloud, identity integration. And if you are like integrating your EDR XDR with SIEM, you can add the richer context for alert. So if any alert triggered in EDR XDR, you can directly integrate it with SIEM, and that's where you can manage it using single pane of glass, and where your 24 bar 7 365 SOC team can monitor these alert and manage everything from a single console. So the alert fire in SIEM, you can pull it EDR process tree automatically and get the context. Also the EDR or endpoint telemetry not in Windows log, it's in memory events like fileless attack. You can detect using EDR and XDR, but Windows telemetry cannot detect these high level attacks. And then automated response via SOAR and XDR. So if you are using your SIEM, suppose you are using Splunk ES and you integrated your CrowdStrike or MS Defender with Splunk, and also you have SOAR running parallelly. So you can take action directly from Splunk console, like isolating the device, running antivirus scan, etc., using SOAR technology. So when isolating endpoints when SIEM detect IOCs on it. So the combination means you correlate EDR finding with network and identity log, and full kill chain reconstruction you can achieve. So the pro tip is be ready to explain the difference between SIEM and XDR. So XDR is natively integrated, faster but less customizable, but the SIEM is broader, more customizable, compliance ready, and most mature organization run both. So most mature organization have XDR tool as well as SIEM tool, but the monitoring can be happen only on the SIEM side, and the XDR event will be sent to the SIEM. So if any additional action required, SOC team can pull the telemetry of the XDR directly from SIEM and also can take action using SOAR. 38. How do you reduce alert fatigue in a SOC? So alert fatigue is equal to analyst seeing so many alert they stop investigating them truly, like every single event start generating alert. So suppose a device generated 100 event and it also triggered 100 alerts. So this is the alert fatigue. So what are the reductions strategies? So you can tune your existing rules. Like you can raise the threshold is 5, you can make it 7, 6, or 10 based on your requirement. And also you can add some context filter and suppress the known good. So you can create a whitelist or blacklist and increase the threshold. And also you can do the alert correlation, so you can use the multiple data sources to get more context, so correlation or connecting the dots. And also you can like group related alert into a single case. And also you can use the automation via source, so auto close low confidence alert. So suppose if uh, virus total shows for the malicious IP score is 1 to 67 or 3 to 67, you can auto close it if you don't see a further action. Then also the rule review, so kill rule with consistently low true positive rates. And also the UEBA baselining, so only alert on the deviation, not on the raw events. So UEBA have their machine learning model, and based on that it create a baseline and detect anomalous behavior when it sees any uh, deviation from baseline or violation of the baseline. And the pro tip here is risk based alerting, the RBA. So this is a Splunk term, is the modern approach. So you can use the scoring rather than binary auto no alert. So currently the Splunk, Sentinel, and Exabeam all support the risk based detection. So mentioning RBA specifically is a senior level signal. 39, how would you detect a command and control beacon in a SIEM? So command and control beaconing is a continuous activity that attacker try to send the data or exfiltrate the data from the compromised system. So suppose there is a system which already compromised by attacker, and attacker have their command and control server at Russia. So attacker started sending data to the command and control server in every 60 second, and the traffic is going here. We can see some HTTP traffic and some post request, some get request. So C2 beacons are periodic check-in from malware machine to like from malware to an attacker server. So this is attacker server. And how you can detect it, so you can use the DNS traffic, like the repeated queries to the same domain. So suppose this is XYZ domain registered in like last week or last 7 days back. So this is a sign of a command and control server. And uh, it is looks like a randomly generated domain like the DGA. So it looks like xyz dot domain, so it's a random generated domain, right? So this is the DGA. And then HTTPS, so a regular small HTTP post and get request at suspiciously consistent intervals. So if attacker install the Cobalt Strike, so Cobalt Strike have default every 60-second request model. And then proxy lock, so consistent outbound connection from one host, especially to the cloud provider or CDN used for C2 like Cloudflare, Azure, AWS, etc. And then also GA3 and GA3S fingerprinting. So you can do the TLS fingerprinting for known command and control frameworks. Statistical analysis, like low standard deviation in connection interval equal to beaconing. And the pro tip says JA3 fingerprinting for C2 detection is a real differentiator to mention. So if you mention it, then interviewer will understand that you have good understanding of the command and control beaconing behavior. And the CrowdStrike and Geek both support this framework. So this shows you understand network label detection beyond just firewall rule. So, what is detection coverage and how do you measure it? So, a detection coverage is like a what percent of known attack technique does your SIEM have detection for? So, suppose this is a MITRE chart and you have deployed your SIEM dashboard where you can see the coverage for each technique and tactic as a use case. So suppose you have two rule created for this technique. For technique 2 you have 5 rules, but the technique 3 you don't have any rule, so this is a gap where you can create more detections. Similarly for technique 4 you have 3 rules, technique 5 you have no rules, so you can assess your coverage and then you can fill these gaps. So this is basically the percentage of the known attack technique does your SIEM have detection for. So this is measured by mapping your rule to MITRE attack and calculating coverage by tactic technique. So the tool like MITRE attack navigator can help you, so you can visualize your coverage as a heat map. And the process is you can export your rule inventory, you can map your each rule to attack technique id, and you can plot it in navigator. So if your technique if your use case doesn't have the MITRE mapping, then you are not able to achieve what you have, like what gaps you have and how much coverage you have. So the gap equal to like technique with no rule, so you can create and fill the gap. So you can prioritize gap based on the threat intel, what ttps are threat actors targeting your industry using, and also you can measure the detection quality, not just quantity. So a rule that fire 5% true positive rate, it's a barely count as coverage. So either you can tune it or you can remove it. Pro tip is presenting coverage with MITRE attack navigator in a slide or a dashboard is a powerful way to communicate detection posture to leadership and pass security audits, because this clearly shows how much coverage you have and how much gap you have, right? So this is a career differentiating skill. All right, so 41, walk me through how would triage a SIEM alert for a suspicious account compromise. So here is the step-by-step uh, method you can follow. So you can first acknowledge the alert, then capture the timestamp, then you can pull the raw events, what exactly trigger the rule, and then user context. So who is this account, and role, department is the critical information, and then authentication history. So is this a behavior usual or unusual, normal login time, geolocation, device detail, etc. Then also you can enrich the source IP, whether it's a internal, external, and you can map it with threat intel, and also the geolocation you can check, and check for MFA bypass. So go to the user's activity and see if the MFA was bypassed or any impossible travel in short time, or is there a token issue. And also look for the lateral movement, so that's a sign of post compromise, and what did the account do after login. And also you can check with users manager whether it is an expected activity or it's a malicious activity, and then escalate or close based on your finding and document everything. So the pro tip here is interviewers love triage walkthroughs. You can use the 5W and 1H formula. So 5Ws are who, what, when, where, and why. And the 1H is how. So this is your mental framework. So, like, who is the user? What did they do? When did they do? From where they performed? Why would an attacker target them? So, all those information you can collect and document. All right. Question 42. What is the incident response life cycle and how does SIEM fit into each phase? So a NIST incident response life cycle have various phases like preparation. So preparation phase have the SIEM is configured, playbooks are ready, and log sources are onboarded, so your preparation is completed. And then number two is detection and analysis. So when the SIEM fire and alert, analyst triage it and then escalate it. So this is the detection and analysis part. Then containment part. So if SIEM used to identify the scope, what else did attacker touch, SOAR can auto isolate the affected endpoint. And then eradication. So eradication is like a SIEM used to verify attackers tooling removed, persistent cleared. And then recovery. So recovery phase have the SIEM monitor to re-compromise during recovery. And then number six, post incident activity like SIEM log used for forensic. So you can export the complete log as a forensic package. Then timeline reconstruction for lesson learned and report writing, the final RCA, and the rule improvement. So you can improve your rule by learning a lesson, what you miss, what you achieved in this rule. So the pro tip says memorize the NIST IR lifecycle phases like preparation, detection, analysis, containment, eradication, recovery, and post incident. So this is a must for incident response under SOC team. And also there is a SANS uh, part which which is lesson learned separately. So SANS have their own framework you can follow for IR. So you can know the both framework, and this will help you to clear the interview. All right, so the next we have you receive an alert. A user downloaded 2 GB of data from your SharePoint at 2 a.m. How do you respond? So you can verify. First, you can verify is the alert accurate? Check raw Microsoft 365 audit log that will help you to get the SharePoint detail. And also you can confirm the volume, how much data has been downloaded or transferred, and then timestamp, file accessed, so what file user has accessed, and then user context. So is this a user known to work odd hours? Are they in a time sensitive project or BIP or privileged user? Then you can do the session analysis of the user. So was the MFA used? What IP access the file, location matches with the user's known location. So if you have the baseline, then you can understand whether it's a user's base location or it's a attacker's location. Then concurrent the event. So any failed login before this, like password reset activity happened for the user account, or new auth application granted permission to the user account. And then data sensitivity, so how sensitive the files that user downloaded, whether it's a PII, financial, or the IP list. And then you can decide whether it's a false positive. If user is working at the late night on a project, so it's a false positive. But if it is not user who is working or downloaded the file, then it is a confirmed incident. And if it is an incident, you can preserve evidence, disable the session, engage the IR team. Also you can notify the HR if insider threat suspected, and also you can disable the user account, terminate the sessions, and also you can send an email to the user's manager. And the scenario is the user is on their notice period, and the file are the entire customer database. So this is very sensitive database, right? And this is an insider exfiltration event then confirmed. So you can escalate immediately to legal, HR, and then IR team. The pro tip is insider threat cases are legally sensitive. So you can mention that you would evolve HR and legal counsel team before controlling the user or taking drastic actions. So this shows maturity beyond just technical response. What is a security playbook and why it is important for a SOC? So a security playbook is a document, or it's a manual for SOC for the alerts. So basically, it's a step by step procedure for responding to a specific alert type or incident scenario. For example, if any phishing email reported by users, so what will happen next? How the SOC analyst is going to handle the reported phishing email. So a playbook contains all the investigation step, like pull it from the mailbox, analyze the attachment, block sender domain, search for other recipients, notify affected users. So Playbook ensures the consistent response quality. So the L1 analyst get the same result as L3. So this help to improve or faster MTTR and SOAR automation hooks. So Playbook become automated runbook and also a compliance evidence. So every common alert type should have a playbook. So if your SOC doesn't have the playbook, your SOC is not mature yet, and it's not compliant as per the industry frameworks. So the pro tip is, if asked how do you improve SOC efficiency, so you can mention playbook plus automation SOAR response is the answer. Also, you can mention that playbook should be version controlled. So it should have the version 1, version 2, and reviewed after every incident where the process broke down. So playbook is very important document for SOC. All right, what is MTTR and MTTD, and how does the SIEM impact these metrics? So MTTD is mean time to detect. So it's the average time from when an attack start. So start the attack to when you detect it. So detect on SIEM. So the complete timeline from starting the attack to detecting it on SIEM. So this is the MTTD, mean time to detect. So a good SIEM with solid detection rule reduce the MTTD from days to week to hours to minute. And then we have MTTR. So MTTR, mean time to respond. So it's the average time from detection to containment and resolution. So it's a time from detection to containment, contain or resolve. So this is the MTTR. So a SOAR integration, a clear playbook, and a proper escalation path reduce the MTTR. So there are some industry benchmark like MTTD 200 plus days is still common. So the IBM cost of data breach have a complete definition, and the target MTTD is less than 24 hour, and then MTTR should be less than 8 hour for critical incident. But this vary based on the organization's need and business. And the pro tip is quoting industry metrics like IBM exports, Mandiant M trend in your answer shows you stay current, and 2024 data shows average dual time still exceed to like 10 days is a credible data point.